My name is Scott Bentley. I'm the president of VideoRay. I'd like to welcome you all to tonight's presentation. The first time we saw Phil Reed speak was our conference in Key Largo in 2008. And Phil said, how long should I talk? And I said, I don't know, Phil, it's an after dinner talk, maybe 20 minutes, maybe a half hour. I said, look at the audience and see when people get restless. For the next hour, I think no one moved at that meeting, and I think this talk could be just as well. This is really fascinating stuff to those of us in the underwater world. I know some of you are from other disciplines, but I think you'll also find his talk is fascinating. Phil was formerly with Titan Salvage. He's now started his own company, Reed Maritime. He is, in our opinion, the rock star of underwater salvage engineering and such. And he's going to talk about his role and the process of removing the largest man-made object in one piece in the history of the world. Phil Reed.
All right, thank you, Scott. Thank you for the nice words. I'm not sure they're all true, but I do have a lot of slides to go through tonight, so I'm going to go at a fairly quick pace. The reason nobody moved for an hour last time is that they were all asleep. So anyway, it'll be a brisk pace so we can get through everything. If you have any questions, raise your hand. Feel free to ask. If you see something on a slide or I didn't explain something well enough, let me know. I think we'll have time for that. I'm hoping that between all my slides and all your questions, we'll be able to get all the way to the end of the Republican debates in California, and then we won't have to watch it. When Scott called and said, hey, would you like to come and speak at VIPS again? This is now my third appearance. I said, sure, what would you like me to speak about? And he said, well, do what you did last time and put up some pictures, tell some sea stories. Everybody seemed to like that. So everything tonight's going to be about the Costa Concordia, of course. But I wanted to give you some idea of the range. This would be the other end of the spectrum. The lighthouse you see here is Horseborough Lighthouse. It's at the entrance to Singapore Straits. Thousands of ships go by every day. And the barge, unfortunately, grounded itself right next to the lighthouse. It's Pedro Branca is the name of the island. It's not much of an island, it's just a rock. And the first pictures that I got of these two cranes, and they are sitting on a barge. You can't see the barge, it's underwater. But the first two pictures I saw of these cranes, they were actually leaning over the lighthouse. When I had the first meeting with the Port Authority in Singapore, they said, I don't care what you do, but you will not let those cranes fall on the lighthouse. So I went out and I took a look, and I came back and called them on the phone. I said, well, I got an idea. I said, if you want to save the lighthouse, we need some explosives. So I won't go too long on this one, but this was a 12-day job. We borrowed some explosives from the Singapore Navy, brought in explosive expert from Louisiana, and we had a great time. We strapped on some shape charges, and we were hiding behind the lighthouse when we pushed the button. They actually let me push the button. So that's the quick and dirty. What I'd like to talk about now is the other end of the spectrum, the big job. This is about as big as they come, probably a once-in-a-lifetime event. But I'd like to go through how the accident happened to begin with, how we planned and bid the job, which was a bit of a go. We had 30 days to do that. And then go through the operations, basically three main areas there, the parbuckling, or rolling it upright, the refloating, and then the tow and redelivery to Genoa. A couple interesting facts to start off with. She was built in 2004, first of her class. She was longer than 3 football fields, over 100 foot wide, It's over $500 million to build new. Of the 4,200 passengers that were on board that night, 32 of them lost their life. And the weight of the Costa Concordia when she departed was around 45,000 tons. And the weight of the Costa Concordia when we refloated her was more than 65,000 tons. So normally the process to refloat a ship is to make it lighter. In this case, we added a whole bunch of weight in order to get it to float. So for those of you, I'm going to go through and give you some idea what happened that night, so you know where it happened and sort of how it happened. The 3 blue dots you see here were her itinerary. She was leaving from Civitavecchia near Rome. She was going to go to Savona, Marseille, Barcelona, on around and back to Civitavecchia. She made it about as far as that red line goes. She was underway before she hit the rock for less than 1 hour. If we zoom into the red box here and look a little closer, you see Rome down the lower right-hand corner. You see Porto Santo Stefano, that's where we took the ferry to get out to the island. Corsica, Elba, some names you might recognize. The little island right there is where the Count of Monte Cristo took place. The most important spot on this map is the one with the dark red pin, Castello Banfi. That was, if you're in Tuscany and looking for some nice wine, I would highly recommend it. We zoom in a little bit closer. You see the island of Giglio, a wonderful place, about 5.5 miles long, 2.5 miles wide. And the incident where most everything happened was on the east side, around Porto. We zoom in a little bit. It's kind of hard to talk. See where I'm pointing. So this is Porto. It's hard to read, I'm sure. Is there any way we can turn down the lights a little bit here? Might make it easier. Anyway, Porto's right here. That's where the ferry comes in. The wreck ended up right here. And this rock down here, known as La Scole, is where she hit. So the red line that you might have a trouble seeing here, this dashed line is the route they were hoping to take. They were trying to go close by the island, beat the horn, in tribute to a Costa employee who had retired to the island. What they did instead was this. So they made a very steep approach. They were coming in quite fast and probably took the turn a little bit late. That's all conjecture. But they hit the rock right there at La Scole. At that point, she flooded 5 compartments. She lost all power. The rudder was hard over to starboard. And she drifted past Porto. She was blown offshore, carried offshore with the wind and currents. She was turned around so that she was facing south from whence she came. And she drifted back and ran aground here at Punta Gabbianara. I think that's right, Mauro. At Seagull Point. All of this was done without any assistance from the crew, only by the grace of God did she land there. If you're standing in Porto and you're looking out at the wreck, you see this. If you're standing on the wreck and you're looking back down at the rock you just hit, you see that little rock sticking off the island. That's La Scole. This is one of the first pictures I took. You see the rock that's embedded in the side. This was broken off on impact after making a long gash. The rock weighed 90 tons. It came out in 2 pieces. The damage gets a little more impressive when you look up close. It's quite impressive to stand there. I think I spent a couple hours on Father's Day with my son, standing right along here, taking it all in. Quite a sight. Those plates are probably all less than 1 inch. Turn of the bilge, they're a little more than they are on the side or on the bottom. So why did she sink? The gash was 174 foot long. It opened 5 compartments, and the Costa Concordia was a 2-compartment ship. And by that I mean she could withstand having any 2 compartments, any 2 adjacent compartments flooded, and she would remain afloat and she would remain upright. With 5 compartments flooded, she was a goner from the time she hit. And the crew up on the bridge should have known it. They would have had bilge alarm sounding and ringing. So they knew right away that within so many hours the ship would be gone. 4 engine room compartments flooded immediately. All the main engines were shut down. The engines produce electricity. Everything on the boat runs by electricity, including the main engine, main propulsion, the stern thrusters, the bow thrusters. So she had no power to maneuver. The rudder was stuck. When she finally wound up on Punta Gavianara, she was listing, they say, or what I was reading on the internet here the other day, up to 80 degrees. But some of these pictures that were taken from the helicopter, the Italian Coast Guard helicopter, looked to me to be more than 80 degrees, and I've read it sometime. At one point it reached up to 95 degrees. And it didn't hit at the bottom and roll over. It rolled over until it hit up high on the wreck, and then the side or the bottom of the ship settled back down. So when we got there, it was about 65 degrees while we were working on it. But these pictures here, I know it's hard to see in these infrared camera shots, but these are actually people standing on the side of the ship, crawling down a ladder they've rigged into the boats. Here's people gathered on the side of the ship, and people crawling down on the stern. I know those are hard to see. If the ship had sunk where that yellow X is, the water depth there, I shouldn't say if she had sunk, if she had capsized where that yellow X is, instead of waiting to capsize when it got closer to the island, the water depth there is 200 to 300 feet deep, even that close to the island. So had it capsized in that location, instead of losing 32 people, it would have probably been closer to 3,200. If it had drifted a little further south and sank or capsized in front of the port, it would have pretty much shut down the island for 2 years, because everything comes into the island on the ferry through Porto. So getting on to the project, quick timeline here to let you know how long things occurred. The accident occurred on Friday the 13th, 2012. We finished up in July 2014. So the days I counted, I might be off by 1 or 2 days, but 827 days over 2 years from the time that we were selected as the contractor. To go through the planning and bidding stages real quick, we had 32 days from the time the ITT was put out on February 1st, and 4 weeks later we had to be in London ready to present our bids. So we had 4 weeks to bid. We were told it had to come out in one piece. We couldn't cut it up. And our first priority was that it did not slide further down into the water. And it was on, it was basically grounded on 2 ridges that ran off the island. So that you'll see later after the post-parbuckling pictures will show you exactly where she was sitting on the rocks. But it was basically on 2 ridges. You could swim or fly your VideoRay underneath the midship section of the ship. This was my first view coming over in a small boat in February. It was quite cold. It actually snowed the next day. You'll see a picture of that in a minute. But it's quite an impressive sight. I have been doing salvage and wreck removal for over 20 years, and this was a sight that took my breath away, I can tell you. We left the island that same day. We drove across Italy to Ravenna. Ravenna was the home of our Italian partners, Micopri. And it snowed that day while we were driving. It snowed the next day and the day following. I think we wound up with about 1 meter of snow on the ground, which didn't make things any easier in trying to put a bid together. There was plenty of help you could find on the internet. I know it's a bit difficult to read that, but can we save the Costa Concordia? Lots of different ideas were out there for us to choose from. This was, we did, I can't tell you how many pictures I have of whiteboards where we just started drawing and thinking and listing all the different things that might be involved. I don't know if it shows up real well, but right there is the number $150 million, which we thought at the time was a big number. Certainly, we had never done a job for that much money. We did get a chance to go to Marseille. The sister ship, the Costa Serena, was in the dry dock there. Another impressive sight, I tell you. This picture doesn't do much in terms of her length, but if you can pick out some items down on the floor of the dry dock and try to relate to this size, and thinking that you have to come and remove this from Giglio, it's quite daunting. I think the thing that struck me most when I saw it in dry dock, that the pictures you see of it laid over on the island, only 1/3 of the vessel is out of the water. The other 2/3 of the vessel are underwater. We looked at trying to refloat it. So we've done a lot of refloating, so pump air into tanks or pump the water out. The drawing here is a little hard to see, but those colored boxes on the plan of the ship are the tanks that we thought might be accessible and available for blowing down. If we had been able to blow down every one of them, I think the total buoyancy we would have gained was about 5,000 tons, and we needed 45,000. So we were a little light. So we could have gone and done some of the larger compartments, but there's difficulties with that because you have stairwells. There's one here. There's actually one, it's hard to see in this photograph, but this is a double stairway. You have elevators for the passengers. You have service elevators, ventilation shaft, electrical wiring, all running vertical. So if you want to put compressed air into a compartment to dewater it, you have to make sure it's completely sealed. And I think to go through and seal all the elevators and all the stairwells, I think the count got up near 75, 80 major patches that had to be installed. So we threw this idea out. This was the pull barge idea for trying to roll her upright. The problem with that is these 3 barges all need to be anchored. The water depth is about 300 feet, and that was a big task. We're trying to pull there. Our guess at how many tons we needed to ride her from that direction was 8,000 tons. So if you're going to pull with 8,000, you have to hold back or anchor the barge is good for 8,000. So we skipped that idea. We looked at taking 2 barges, putting one barge on top of another one, sinking the barge, rolling the wreck onto the barge, and then refloating the 2 barges. The only thing wrong about that is we actually needed to do that 4 times in order to have the capacity to raise the 45,000 tons. So we threw that idea out. Just to show you that this idea actually came from somewhere, we actually did this plan. We called it the anti method in Malaysia years ago. So we took a perfectly good barge, we sunk one end of it, we pulled the wreck up onto the barge and refloated the barge. So we were trying to take some of our past experiences and find something that worked. There was one gentleman on the job, Marco Bertoli. He was sort of our agent, and he has the funniest story about these slides right here. We called this plan started as the Chinese fan, and it ended up as the pizza slice, obviously because we were in Italy. And the idea was to have a custom-made bag and fill each one of these colored sections up with high-pressure water or some sort of incompressible gel and slowly jack the vessel up. When our partners heard, or I tried to explain this to our partners in Ravenna during the snowstorm, the owner of Macopri, I think, decided there and then that I had never gone to college. Slowly but surely the plan came together. And this is one of the first plans that started to look like what we actually did. So this has a sponson on the outboard side here. This is a strand jack. You'll learn a little bit more about those in a minute, but it's going to pull this wire that comes all the way down attached to this pile, which is driven into the bottom. And because of the slope, we needed to have something to land on. So in this idea, we were going to pour a lot of granite gravel. The island is made of granite. I figured pour some gravel there. We could leave it at the end. It's all natural material. And we would pull against this pile driven into the ground. So this is when we actually started thinking, hey, we might have something here. It went through a few stages. This is the L-shaped sponson, which we did away with eventually, but you can see now that the platform idea has taken over from just pouring some gravel. This set of drawings kind of gives you the final plan that we came up with. We were going to roll it with, we're going to put the sponsons on the port side. They were going to be welded on. We'll go through that. We're going to pull off the platform we installed. There'll be some grout bags under the corner. And once it was upright, we would put the starboard side sponsons on. I know you have a hard time seeing some of these pictures in the back, I'm sure. And then finally refloat it. But you'll get some other views of all this stuff. Again, there was a lot of help from the internet. As word leaked out, we came up with some great indentations of what we were going to do. They have the grout bags down here, they have the platform, they have the sponsons. And I really appreciated the colors they used here because they actually showed some rusty sponsons and a rusty hull. Most everyone else had them beautiful white. Again, hard to see, but here's what happens if it topples over, if it falls over, if it breaks apart. So we got a lot of encouragement along with some of these ideas. These are the drawings we actually came up for the presentation in England. So all this was done in, probably the last 2 weeks of our 4-week bidding phase. Oops, sorry. You see the grout bags underneath. You see the platforms installed. There's some structure on the side of the ship to receive the sponsons. This kind of stepped through how we were going to parbuckle. Once parbuckled, we'd put on the starboard side sponsons. We had holdbacks coming here to keep the ship from falling down the hill, and finally the refloat. And the best picture I had during the presentation, and for the first 2 hours in London I presented the technical part of our bid, was this drawing. I call it the component drawing because it shows all the bits and pieces for the parbuckling. So you have the holdback. So this was holding on, actually went around the ship up here and attached on this side. That was to keep it from sliding down the hill. The grout bags were to support the corner, the turn of the bilge during the parbuckling. We're going to land on the platform. The port side sponsons are installed. So let's step through some of these operations or some of the things we had to do leading up to the parbuckling. So there were 6 major tasks. Each one of these tasks was a major salvage job unto itself. Each one of them had a salvage master. Each one of them had its own team, dive teams, video rays, etc., etc. So the first thing we'll look at is what I call the port side prep. We had to prepare the whole port side, which was in the dry, to receive the port side sponsons. And so if you look at this picture here, it looks, this is the promenade deck, I call it, deck 3 on the ship. So if you were on board during the cruise, you had a nice dinner and you wanted to go out and have a cigar, you'd come out to the promenade deck and you'd walk up and down and watch the full moon rise or set. What we lived with was that deck turned this way. So the small deck you see here was installed by the crew. It ran from one end of the vessel to the other. And what used to be the promenade deck became a nice place to hang all your loose tools. These are all the welding leads run up and down. We had 40 to 50 welders on some days welding on the side of the ship. So being neat and tidy was very important. You see the other gear stored along here. So here you are on the port side. You see the strips there. That was a deck scaling machine. They laid down the track and the machine ran along the track. And they removed the paint where the port side sponsons were needed to be welded. And everywhere you had that strip of cleaned paint, they welded, it's hard to see here, but they welded a doubler plate, flat bar, I think about 1/2 inch thick. And all of that was going to receive the port side sponsons. These are the anchor points. When the sponsons landed later on, they landed on these anchor points, which held them in place while the guys welded them on. And the pad eye you see there will be used later on for the holdback. We'll see a little bit more of that later on, but remember the pad eye. We called these plates here the gash plates because they went across and over and covered the gash. That prevented the chains that were eventually going to be hooked into these pad eyes that were going to run all the way under the ship and back around to the other side. The gash plates prevented those from cutting into the turn of the bilge. We thought that was going to be a problem. In the end, we never saw much sign of that at all. The next thing, and so while these guys are busy working on the port side, we have another team. I think Morrow is a big member of this team, installing what we call the holdback. So you see a bunch of towers here installed behind the wreck. That was the final second stage holdback that was eventually installed. I won't spend too much time here. This is just a drawing of where each of the anchor blocks need to be positioned. Each one of those anchor blocks received one of those towers standing on top of it. There was a lot of work done by geologists on the rock formations and how many tendon piles needed to be drilled through into the granite to hold these blocks in place. What you see sticking out here is the tendon pile. So when they placed the block, they had 10 holes to drill. That's 1, 2, 3, all these white holes with the 10 original tendon piles. So they drilled down 15 meters, 20 meters. They put the tendon pile in. They grouted the pile in place, and a couple days later, they came back and tightened this down with a torque wrench. And it was the friction of these 10 tendon piles holding the block down on the granite rock that kept the block from sliding out and holding the ship back. Eventually, when they realized that a lot of the rock formation itself was cracked and had fissures and whatnot, those those colored dots represent the additional tendon piles that had to be drilled and put in place to make sure that the rock formation under the anchor block was strong enough to hold the anchor block. So this went on for some time. This is a picture of what the anchor block looks like. It has 2 grommets, one on each side. There's a bollard that sticks out either side. If you look here, you see the red spot here represents the anchor block. The wires run underneath the ship. They come up underneath the ship and to the port side. And on the port side, we had 8 strand jacks. Again, you'll see a better picture of the strand jacks in a minute, but they basically can pull, these particular strand jacks can each pull 400 tons. So once everything was connected up, we tightened up the strand jacks and we had the ship wrapped 8 times. And that was our initial holdback. And I think originally we told them we were going to put in 12 and we were going to get a bonus for that. And somehow the engineering got that down to 4 anchor blocks, 8 grommets, and 8 strand jacks. And I think in the end, we made some money on the bonus for installing our holdback. I'm not sure it would have held it back, but it was installed nonetheless. Difficult here, the slope of the bank in some places was quite steep, and so in order to install an anchor block, we had to actually carve out a place for the anchor block to sit. And we did that with what they called the pecker. So this machine here would actually go down and dig into the granite. It was at the end of an excavator arm, up onto the barge, and for hours and hours and days and a few weeks and months, Morrow sat there and watched the sculpting being done. A bit difficult to see, but this is the original edge of the slope of the rock granite, and the block is sitting way down here, so you can see where it's actually carved its way out of the back. To give you some idea how big the blocks are, here's a diver being watched by VideoRay, and here's the bollard on the block itself. So they were quite big. Another diver just trying to put together the rigging for those blocks. Another picture to give you some idea how big these blocks were. These are the towers and how the tower fit onto the block. They're doing a test fit in the dry. All of this had to be done and installed underwater once the anchor blocks were put in place. And in the end, the towers were topped with strand jacks. So what happens is the strand jack pulls up, the extra strand that's coming out the top of the strand jack goes over the top of the saddle and hangs back down. So what happens is the rigging's quite big and quite heavy. The grommets were 120 mil grommets, so they're 4 or 5 inch wires and quite long. There was some chain involved later on. So it takes a lot of pull just to stretch that rigging out and make it tight so it can be effective. So each one of these, I believe, were 600-ton strand jacks. And at the other end of the strand jacks, for the final holdback that we used during the parbuckling, the strand jack went down around the bollard, under the vessel, and up to the port side where it was attached here to the anchor points installed by the port side prep team. Those are 5-inch chain. That means the link chain is 5 inches in diameter, and it stands on end about this high. So the crane's having to pick this up. We're having to pull it over to the other side. It's quite a feat just to install those chains. All right, platforms. We needed somewhere for the ship to land once we pulled it over. Picture showing where the platforms will be located. There's 3 big ones. Eventually we had to put in 3 small ones to hold the stern up. You'll see here 26 holes that we had to drill. These holes were 1.8 meters in diameter. They were drilled in, that's about 6 feet. They were drilled in 35 to 45 meters of water. They were drilled into granite. They had to go into the granite about 20 meters. Sometimes the granite was sloping this way, and sometimes it was sloping that way. You never knew. Occasionally there was up to 4 meters of sand that you had to drill through first before you got to the granite. And then, of course, we tried to do all this from a floating barge in the middle of the winter. This was the most frustrating task that I was involved with. These are the platforms being constructed in Ravenna, the other side of Italy, so they got to be brought all the way around. There is a truck right here, so you can get some scale of how big these platforms are. I don't remember, do you remember the weight, Mauro? 1,200 tons per platform, and there was 3 big ones. This is a template that they made up. The 4 long tubulars you see sticking up are the jacks, so when they put it down on the bottom, they can level it up. Once it's level, they can drill through the guides here. And that way, when they bring the platform out, there'll be 6 legs that need to be stabbed. You'll know that they're all in the right spot. They're all standing straight up and down. There was a little bit of tolerance to be off center. There was a little bit of tolerance from being off vertical. But to get 6 big piles is stabbed with those platforms was quite a feat. So they put in the template. They leveled it up with the jacks. This is the conductor pipe. So the conductor pipe's picked up by the crane, stuck through the guide. They put the drill head on top of that, and they drill, and they drill, and they drill. And they would have trouble because the slope of the bottom was so steep, and as they tried to drill, the drill wanted to kick off instead of bite right into the granite. And that would kick the template off. And then once the template was off, they had to start all over again. So quite frustrating, but they did manage in the end to drill all 26 holes. And when we did bring the platforms out, there wasn't any problem getting them stabbed and into place. Here's the platforms coming out on the barge. We had a heavy lift ship, the Salvage in this case. She'd pick the platform off the barge. She'd bring it alongside and lower it into the water. Might be hard to see, but there are, along this back edge, some yellow pad eyes. Eventually, we're going to hook to those pad eyes and use those pad eyes to parbuckle the vessel upright. Those pad eyes, when everything was lowered and she was grouted into place, was probably about 15 meters below water. Okay, so we got guys working on the port side. We got guys pecking the granite on the other side, putting in holdbacks. We're trying to drill holes for platforms. We have another team living on the Pioneer barge, which are installing the grout bags. I think in the end we installed 13,000 cubic meters of grout underneath the Costa Concordia. This is a picture of the platforms again. These green trapezoids represent the original plan to place grout bags. One reason we couldn't drill underneath the ship, so we could only bring the platform so far. So from where the platform ended and those big fences you saw on the platforms, we had grout bags. In the end, I think everything from here to here got grouted, and of course we filled in this area here as well. This is sort of a 3D view of how they envision the grout bags. Again, fitting right up to the fence on the platform. So that was all straight across, giving us a nice place to land the vessel. This is the grout plant on the Pioneer. It's where all the grout was mixed. We had ships running constantly, or a ship running constantly from the island to shore to bring back more cement. Just the logistics of getting the cement or the grout on location so it didn't hold up divers was a huge task unto itself. This is the other end of the barge. This is the barge where the divers went in the water. And this little container here was the control center for the VideoRay team. Bad pictures, I tried to pull them out of some of the videos we had. I don't think it's VideoRay videos. I think it's from the diver's hat camera. So, but you can kind of get a feel for how they stacked the bags down there. The bags came from India. They were, some of them as long as this stage. They'd put them in place, they'd strap them down, they'd take the hose from the grout plant, stick it in the bag, and just go until it was full. Some they filled nice and tight, some they left a little slack, depending on what they were trying to do. But the stacking of the bags in the end, and I'm sorry I don't have a good picture of it, but it was unbelievable how nice and neat those bags are stacked. And then when we needed a certain shape of the stack of bags, they are actually able to pull it off. Quite impressive. There we go. Okay, so now we have to install the port side sponsons. The port side prep team's done all their work, and the sponsons are quite big objects. They're built in 3 or 4 different places in Italy. They all have to be transported to the site. This is a quick map or drawing of where all the sponsons are going to go. There's 15 on each side. This drawing changed and changed and changed until it was finally agreed to put them on in this configuration. You'll notice that 4 of the sponsons are horizontal. In the original design, there were no horizontal sponsons. This was a change that was made late in the game because it made a huge difference on our shear and mainly our shear, but our shear and bending moment calculations in regards to supporting the ship. You notice that the 4 horizontal sponsons are right in the areas, or as you'll see in a minute, right in the areas where she had the worst damage. The tall sponsons are 32 meters high. The short sponsons are 20 meters high. And otherwise, they're all the same, 10 meters by 11 meters, 10 meters wide by 11 meters long. Of course, just handling these sponsons shoreside was a big problem. They need to be outfitted. They need painting, rigging, pneumatics hooked up, electrics hooked up, that kind of thing. And so Fagioli, one of our partners, designed these nice, neat little tools for rotating the barges. So whichever side you needed to rotate, you could easily spin them around, do what you needed to do, and get on to the next sponson. Eventually, the sponsons came out on the Loney. This is the first sponson, P10, a tall sponson that was installed. So the tall sponsons were about 800 tons each. The small sponsons were 400 tons, 450 tons each. So the crane on this heavy lift ship is 1,000-ton capacity. And I think she used every bit of it to put this in place. So that was the first sponson landed, P10. Here's the guys doing the final fit up. You'll see the anchor point that had been installed earlier fits right into this cutout on the sponson. And there's 4 of those. So when they set them down, the sponson rests on these anchor points. It gives the welders a chance for the next couple of weeks to weld her down in place. Each of these sponsons is a couple thousand tons of buoyancy. So the welding that's required to hold on a couple thousand tons is quite significant. We had surveyors that measured the exact shape of the side of the hull, and they trimmed the plates on the sponsons to match the hull. So when they set it down, the gaps that the welders had to fill was minimal. Wasn't perfect, but it was pretty good. Picture showing all the port side sponsons installed. So that's done. Now we have the last task, and this is the blister tanks. The blister tanks were not envisioned in the original bidding of the job, but it included 1,500 tons of steel and about 5,500 tons of additional buoyancy. There was a storm on Halloween night in 2012, the first year. There 6-meter waves were predicted, and I think we got every bit of that. I was fortunately on the other side of Italy at an engineering meeting. But the results of that was that the ship moved quite a bit that night. They were measuring from the hill, and we were measuring from on board the position of the ship and her trim and her heel, whatnot. It was closely watched by all. But if you remember this picture that we had earlier showing the damage, this is the same turn of the bilge, a little bit further forward on the ship. You can see how much deeper the turn of the bilge is here than it is in the previous picture. So the vessel dropped over or close to a meter, and it rolled away from shore about 1.3 meters, if I remember correctly. And that all happened overnight on Halloween. So you can imagine everybody got pretty excited when they saw the readings the next day on where the ship was. Fortunately, that was the only time we had big movement in the ship, and but that led to this idea that for the winter time we needed to have some support on the bow, which was pretty well hanging out, over the edge. This was the first idea what to do with the bow. So we take a tall sponson, we kind of build this section in here. I don't know if you can see there's the shape of the hull in here. So that was the first idea. It's going to turn out here in a 3D view. My idea was to make a mold of the ship, roll the plates, build this box, and slide it over the bulbous bow. Because remember, you're talking about several thousand tons of buoyancy here, and somehow you have to hold on to it. So it's easy to put something down there, but how do you pump it out and then hold on to it? So one of my ideas was to incorporate the bulbous bow and let that do the work for us. The final design turned out to be a shape something like this. It fit in both sides here. Better picture coming up. And this is what it was going to look like. So this is the blister tanks installed with the vessel removed. So what you have is 3 green tubulars. What we did is we went to the bow thrusters, we removed the impellers, and these 3 tubulars were fit through the bow thruster. And they were all done at one time, and they were all connected to that purple plate. So we had to put them down, bring them back up, stab them through the hole, and secure them in place. And then bring the red blister tanks out and attach those to the green tubulars. Sounds easy. The artist rendition of the installation process. Here's the blister tanks arriving in Palermo. They were built somewhere else, but they were to be outfitted in Palermo. You can see the guys standing here again to get some scale how big they are. This is the blister tanks and their test fit up inside the building at the shipyard in Palermo at Fincantieri. Again, there's a couple guys standing right here. You probably have a hard time seeing, but the scale of these things is just amazing. To stand there and look and figure out how in the world are we going to get these down under the bow and connected. It was quite daunting as well. This is one of the blister tanks on the barge getting ready to be transported up. You see all the different tubulars that are going to be used to connect it to the other side. And the 3 red circles there are where the tubulars, the green tubulars from the last photo, are going to be connected. There's some hydraulic pins that lock them in as soon as we can get everything lined up. So that's 6 pins to get lined up on something quite large. It's a very difficult task. Next to the drilling of the holes for the platforms, this was probably the single most difficult task that we had. So the barge arrives on the blister tanks arrive on the barge. It's picked up by the, I think by now this is the Svenja, not the Loni, same size, same vessel. She's going to put them in the water where they're afloat, and the load's going to be transferred only on one side to the hook of the M30. To the M30, that belongs to our partners, McCopry. This is this is the upper corner of one of the blister tanks, the port side. So the other one's now already underwater, and we're trying to jockey it in position and make the connections to the 6 green tubulars. This is her in her final position. This is the artist indentation of her in her final position. I can tell you that these were some extremely long days. Mauro knows we were up, I don't know how long, sitting in the control room trying to figure out how to get the very last green, the very last pin in through the green tubular. I know we all went back and got some sleep and came back the next day and tried again before we finally jiggled her enough to get it in place. But the problem is the ballast tanks are not square, they're not rectangular. They're an odd shape, every one of them. So if you take out a meter of water, it changes the center of gravity and the center of buoyancy by so much. And if you take out another meter of water, it doesn't change the center of gravity and the center of buoyancy by the same amount. It's different. So every time you adjust water, the thing reacts differently. So it's quite a challenge to get everything hooked up there. But in the end we did, and we had another 5,500 tons of buoyancy on the bow that originally we had not planned for. So now we're ready for parbuckling. The blister tanks are in place. We have the sponsons, the platforms, the grout bags, the holdbacks. We're ready to go. That's hard to see. I'll skip by that one. So here she is, our command center during all of this. We're in these containers on the barge Paluche that was moored right in front of the wreck, so we had a bird's eye view. The strand jacks, I'll see here, I'll show you a good picture of the strand jacks up here, but this just shows they're all tight. We're getting close to starting the pull. So here's up on top of the wreck. This is the top of the sponsons. You see the strand jacks here. There's 4 strand jacks on each sponson. They're all good for 600 tons. Look from the outside. These are all the strands, the excess strands coming down on the outside. But what's happening is from the strand jack here, there's strands going down over the corner of the barge, and they're being connected to those yellow pad eyes on the platform I pointed out earlier. So the control room, from the inside, we had some large screen TV set up with all kinds of things, cameras and readouts. One of the readouts was this, and this is where we kept control of the whole parbuckling process. Each sponson, this is P4 through P12, as we had installed on the side. They each had 4 strand jacks. These show the hydraulic pressure and the actual pull of each strand jack. And we had the total up here. Of course, in this case, we're not pulling anything. I think the maximum pull was about 6,800 tons, if I remember correctly, something like that. This is kind of how it looked from the command post at midday. We hadn't come very far, but she had started to move. By 6 o'clock, we were all feeling like, hey, this is going to be pretty easy. By midnight, and there was some struggles between here and there, but by midnight we were starting to get over the top dead center point where she'd go on her own. And by 4 o'clock in the morning, we blew the whistles and all went home, went to bed. And she was upright. The next day, that's what she looked like. From this vantage point, it's real easy to tell the first-class side of the ship from the third-class side of the ship. Yeah, she's like a rock now. She's sitting on the platforms of grout bags. We were worried that the lower turn of the bilge would collapse. It was already in pretty bad shape, so it's hard to tell whether it collapsed or not, but maybe a little bit, but nothing that we noticed. You know, from where we were, it was almost, very, very little noise at all. A little bit in the very beginning. Oops. You see, there's some debris down here in the boom we put around her. There was some debris, but not near as much as I thought there would be. This is what it looked from the vantage point up on the hill. This area up forward and this area back aft are obviously the two areas where she was sitting on those two ridges I was talking about earlier. So looking a little closer, again, here's the forward damaged area. It's quite intense standing on the inside in some of these passageways and seeing what it had done to those outside cabins. So if you go on a cruise ship, make sure you get the inside cabins. Again, here standing on the ship, looking at this same damage, standing on this side, taking the picture, looking forward. You can see everything, all the outside decks were bent up. A lot of the rooms were in pretty bad shape. This is the aft end damage, very similar. This is standing outside one of the rooms looking down. You can see everything's just folded back in. This is kind of interesting. We used an engineering company in Hamburg called Overdick, a company I've done a lot of work with over the years. I made sure that they were part of this whole project. This is a finite element model that they did of the wreck before the parbuckling. This is a laser scan of the wreck. It was actually laser scanned above the water and below the water. If you could get a laser scanner on a VideoRay, that would be a great tool. Hint, hint. So this is what she actually looked like afterward, and this is what the engineers predicted she would look like with the finite element model. There were over 1 million nodes in this model. This is a cross-section out of the same model, and I can tell you, having walked on some of those decks, it was, when I went back and did this comparison, it was really amazing how well they were able to predict what the ship might look like when she rolled upright. Okay, once she's upright, now what we have left to do before the refloat is to install the starboard side sponsons. But the port side sponsons are easy. We put them down, we welded them, they were done. On the starboard side, we can't do all that welding underwater, so we attach them with chains and wires. So each of these sponsons, and there were a couple special cases, but more or less we had wires that came from strand jacks on the outside and kept the bottom pulled in. That goes all the way around and connects on the port side. And then to actually hold the sponson down, remember each sponson that at its worst case is going to have roughly 2,000, 2,200 tons of buoyancy that we have to hold. And it was being held on 4 chains that ran from the other side, the same anchor points, same chains that were used for the holdback during parbuckling, got disconnected from the towers and reconnected to the sponson. 2 strand jacks on the sponson. So we have 4 600-ton strand jacks holding each sponson in place, along with the wires. So here's the starboard side sponson sitting in Livorno, getting ready to be outfitted. These are the where the strand jacks are going to sit on top of these tubulars. When they made the sponsons short, they didn't realize that once they were in their final position, the top of the sponson would be underwater. So they, I'll get to that. Let me see, we'll jump right to it. There we go. I don't know if my batteries are dying or not. All right, so there's a strand jack. So I promised you'd get to see a strand jack. This is the top of the strand jack, all the strands. They're about as big as your little finger, I think 18 mil. They're gathered here together, and they go up and over the saddle as it comes out of the top of the strand jack. This is coming out of the bottom. This is the plate that'll sit on top of the sponson. And all of these had to be rigged in Livorno and then put on the sponson before they came out. What I started to say was that this short sponson, the top of the sponson is underwater when it's in its final position. We didn't want to put the strand jacks underwater, so we had to come back and build towers for them. All of this is engineering that evolved as we went along. Somebody said one day, hey, let's make short sponsons because we don't need 30 tall ones. And then a month later, somebody said, oh, we have a problem with the short sponsons, and now we need to come back and we need to build the towers. So this is just an ongoing process. Every day there was a new change, a new twist. And the engineering, so it started in January of 2012. We got a bonus in August 2012 for having completed all the engineering. And then I think we engineered right up to the time we got to Genoa. These are the sponsons arriving on site. You can see they have, they have 4 strand jacks for the wires, 4 for the chains. This is an 1,800-ton crane we needed offshore to be able to install these. This sponson, the short sponsons, as you see them, are about 450 tons. The tall sponsons are about 800. This is a tall sponson being put in on the stern on the port side and stern on the starboard side. In way of the damage, we had to come up with some way to support the sponson. We couldn't just let it flop around and fit its way into the area of damage. Some of the decks inside the cabins look like that. That's a piece of steel folded up into the cabin. So what we did is we cleaned everything out. We put steel beams down on the deck. Welders welded them all down. And they look kind of like this, sticking out with a plate on them. So the rub rail for each sponson, 1, 2, 3, 4, would each fit to 1, 2, 3, 4 supports in way of the damage. So this, again, this was engineered, after parbuckling and all installed as part of the starboard side sponson installation. This was the starboard side S15. You see, there's where this is the rub rail from the sponson. It should be fitted here, but the whole sponson is slid back on us, trying to hold it in place with turnbuckles and chains. What we did is just put another piece of beam in there and let it ride on that. So there's a lot of changes made along the way, and occasionally we would get the sponson come up under a deck. So what we ended up doing is just welding steel beams from the deck to the overhead all the way up and down where we had this type of problem. But eventually we have the starboard side sponsons being installed here. You see all these are underwater. The strand jacks are above the water. And here I think we're almost all the way complete and ready to go for refloat. Refloat, this is our ballast system. It was actually a compressed air system because we didn't pump the water out of the sponsons. We blew air into the sponsons and we blew the water out of the sea chest valve. This is a ring main system. It went all the way forward around the bow, all the way back around the stern and back to here. We had 2 crossovers. We had 4 1800 CFM compressors. So if you're familiar with compressors, you'll realize how much air that was. Each sponson had a control box like this, and all of that fed into the control room. Again, the same control room we use for parbuckling, we use for refloating. There's quick shots of the stability software and the longitudinal strength software. Most people were concerned with the bending moments and the shear forces on the ship. With all the sponsons, she was quite stable. Don't try to read this as a spreadsheet that we use. This is actual refloating plan. There's 34 columns. Each column represents a different stage in the refloating. We won't get too much in that. This is the screen we use to control each tank, so we'd open and close valves and blow the tanks down. It was quite automated. We could actually get 5 tanks from our spreadsheet that needed to be pumped in that stage, program that into the system, and hit go, and the program would actually blow the 5 tanks down. So one would go from 98% to 75, one from 50 to 25, one from 25 to 0, and the whole system would run on its own. I didn't really trust it. I like to do it manually because we didn't have a whole lot of time for testing, but it was quite a system. Then we could view all the tanks at one time, see what we had. This is starboard side. We had the same view for the port side. This is shortly after refloat. I can tell we're afloat because we have a diver down checking on chains. On the initial refloat, there were 5 sponsons on the starboard side that were not active, as we said, because we couldn't connect all the chains because she was laying on the rocks, and the rocks were in the way of passing the chains over. So this is the diver going down, making sure all the chains are clear and free. There were a lot of video rays running underneath her at the same time, checking damage and whatnot. But eventually all those chains were connected, and we brought all those 5 sponsons into play and made our final push for our towing draft. This is the bow, a couple shots I took. This, of course, is before we started. This is after the bow's dry with some growth on it. This is the next day after the guys went by and cleaned up with a pressure washer. The 2 circles you see there, that's the cruise hot tubs. So this was our departure day. It was quite an emotional day on the island, I'm told. But we headed out. It was about a 4-day tow up to Genoa. This is our arrival in Genoa. I think I counted 8 tugs that all assisted in getting us tied up alongside a little port called Voltri at the west end of Genoa. And this is my last view of the Costa as I left to go home on August the 7th, 2014. How much did it really cost? Well, we always thought if we were going to refloat it and have it repaired and put it back in service, nobody would ride the Costa Concordia again because we were going to have to call it, rename her. And the choice we had for the new vessel name was cost a lot of money. And it did cost a lot of money. The settlement, from what I'm told, for the wreck removal only, which is what we did, getting her to Genoa, was just under $1 billion. If you'd have told me one day that I would do a wreck removal job that cost $1 billion, I would have told you that it had to include a nuclear aircraft carrier, a very large tanker, very large container ship, and a cruise ship all together at the same time. It was amazing. There were 500 people on the island at certain times working on this. There were things being built all over Italy, so we had to have people there watching, managing contracts, managing fabrication. It was such a big project, well beyond anything that we had ever done before. It was quite a team effort. You see some of the other costs there. Some of those are guesses. I know the scrappers who are still scrapping the ship in Genoa had about $100 million. And when I showed up in Genoa, I said, well, we did the first half. Now you got to do the second half. And the guy's response, well, that's okay. He said, that's not fair because you guys had got $1 billion and we only got $100 million. So, the numbers are just staggering. What happened to Captain Schettino? He was caught with his mistress, wrecking a cruise ship, 32 deaths. And what did the Italians do? They put him under house arrest for 6 months with his wife. For me, they would have not had to have done anything else for punishment. He did this year get sentenced to 16 years in prison, broken down as shown on the screen. I think it's currently under appeal. Morrow can fill you in on the details. He did come under a lot of ridicule. It's one thing to wreck a ship. It's another thing to jump off the ship while there's still passengers on board. I think that's where he, got into his biggest trouble. There was a lot of ridicule here. This was one of my favorite ones. It says here, Fabrizio Rossi Biaggi. If you're Italian, you recognize those as famous motorcycle racers. And then, of course, here at the end, Schettino. for those of you into fashion. Next time you go on a cruise ship, you'll know what to wear. It was a great team we worked with, Italians, Americans, South Africans, Brits from all over Europe. It was just amazing. Great team to work with. 31,000 tons of steel fabricated, 9 tons of welding rod consumed, 33 kilometers of weld, which I think is a bit low. 13,000 cubic meters of grout, meaning you could probably fill this building several times. 13,000 individual dives. And of course, 8 VideoRay Pro 4s and 50,000 hours of video. What's that? 55, excuse me. I would like to make a small dedication to all 32 who lost their life. On the last day I was in Genoa before I left, I took the scrappers around and we talked about a few more things. And then I heard that Kevin Rebello was on the dock. Kevin is Russell's brother. And the fire brigade was on the dock getting ready to start searching for his brother, Russell. Russell was the only body that wasn't found up until the time we delivered the ship in Genoa. I'd met his brother Kevin and Giulio a couple times, so I went down the dock to say hello. He was standing next to a Coast Guard captain and a lady from Costa in a nice dress. And I asked him, I said, "Have you been on board yet?" And the captain looked at me and the lady looked at me and her eyebrows went up. And he goes, "No, can I?" And I said, "Well, if you want to, let's go." And I guess they couldn't say no to letting the brother of the last missing person go on board, so we proceeded to do a nice tour of the vessel. We went around to where Russell was last seen, Deck 4, lifeboat station number 7, where he was seen helping people get into the lifeboat. But he went missing, and they didn't find him until last October, when cleaning out one of the inside cabins, he was found. But anyway, his brother was a great guy, and I'm glad he got closure, so a shout out to Russell. In terms of VideoRay in this project, there could not have, I think VideoRay was made for this project or vice versa. It was an absolutely great tool. Visibility was unlimited, so that helped. The currents were negligible. The depth, 100 feet, was just about a perfect working depth to stretch out your umbilical tether. And on top of all that, there was a lot of things to monitor. 13,000 dives, and I probably bet 12,000 of them were recorded by VideoRay. Why come to VIPS? Well, in 2008, I did my first talk at VIPS, and afterward I had a guy come up to me and he said, "Here's my card. If a cruise ship ever capsizes in Italy, call me." So as soon as the Costa capsized, I called Mauro Stasi. And just a note that I know a lot of you here are operators of VideoRay. I'm not an operator. I'm an end user. I think they're great tools. I let somebody else fly them and show me the video. We were constantly taking snaps out of the video back to meetings in Ravenna and Milano and Parma and Genoa. It was a great tool to bring the engineers and the operators together, so to speak. So, I think VIPS is great for operators. It's also great for us end users. It gives us all a chance to get together and talk about what we can do to improve things, such as underwater laser scanners. Thank you very much. And I'm more than happy to answer any questions you might have.
To remind you that we have questions coming from the internet too, right? So if you've got a question from the internet, put it on, type it in, and we'll ask Phil. Where's our planted first question?
Yes, I think there's a microphone coming around for you.
How much did each individual link on the big chains weigh, just to get an idea of the weight?
I would say over 100 pounds for sure. Okay. Each link. Yeah.
Okay. Thank you.
Oh. Yeah. I haven't been back myself. I was talking to Morrow about that today. You know, Giulio is very seasonal. So before the wreck, you know, if you went in July and August, the place was packed. And if you went December, January, it was a ghost town. And while we were there, it was still kind of followed those same rhythms, although we kept 300 or 400 people there steady through the winter. So you probably found a few more restaurants open than you normally would. But I don't know, Morrow's probably a better one to ask that question. I think there's still a team from my Copery doing a cleanup operation. So all the grout bags that we put down, they're cleaning up all the inside of the wreck that came outside. You know, deck 6 was completely emptied over the winter after we parbuckled. The water line was through deck 6, and everything on deck 6 was outside the wreck. Everything, sinks, beds, carpets, wires, lights, you name it, was gone. So there's a huge cleanup going on even now. And how many people do they have, Morrow? He said around 100, and most of them are living offshore, not onshore. So imagine it's, you know, not nearly as lively. September, you're at the end of the season, so by October the weather gets bad, and, you know, it's just the locals. So, yes. You ask what was the biggest failure and how we overcame that. I think drilling the holes for the platforms. I didn't go into a lot of detail, but we ended up with this stuff called water glass. I had a lot of trouble when we had the slope and we had 4 meters of sand. So the conductor pipe, we had to vibrate down till it hit rock. And we had no idea which way the rock was facing, whether it's level. We had to excavate the sand from inside that tubular. So, you know, it's tubular like this. And it's, you know, you vibrate it down, it's full of sand. You got to get rid of it so you can put the drill bit down there. And as you suck the sand out, because you're on a slope, and the conductor pipe sits like this, as you suck the sand out the top, more sand just fills in, and it undermines your template. The template moves, you got to start all over again. So finding ways, we used a product called water glass that we could pump. We had to inject into the sand, and 12 hours later, the sand was firm enough that we could excavate it and keep the sides where we get the drill bit down there. Probably didn't make a lot of sense what I just said, but the troubles with drilling those holes, that January of 2013 was a long month. Yes, sir. Yeah, even while we were there during different portions, we were actually, the guys would say, hoovering the bottom. We had suction, we'd go around, and the pouring of the grout, the sculpting of the granite with the pecker, produced lots of sediment. And for a lot of the scientists, it was the small sediment that was the problem, not the big grout bags. Grout bags are easy to remove, but how do you clear, you know, a big area of all this sediment? And sometimes the hose would come out of the grout bag and spill a little grout, and all that would get real fine and tripped off. So I don't know exactly how they're going about the cleaning process now. They've been at it for a year. I think they started about October last year. And I imagine they're going to be there for a while. I mean, the grout bags would come up, and what happens is a pocket of air that was in the bag, and when they bring it up, it expands. So it's sitting on the deck, and you're talking to your friend, and all of a sudden, bang. You know, so I know they've had some of those sort of instances, but it'll be a long process. It's a huge mess. Just the rubbish from the ship that came out is quite amazing. Yeah, there's some standard contracts from BIMCO. This was a BIMCO rec hire contract, meaning it was a day rate contract. So we had a plan, and the plan changed all the time. And so there's a change of circumstance clause in there, and you just go back to them and say, hey, this is what happened, and be it a storm or took us longer to drill the holes or whatever it might be. So, but it was such a big job that everybody knew with just 30 days to plan. You're really just guessing. We were the highest bidder at $288 million, and thought there's no way we're going to get this job. We just bid it high. But yet we were selected because we had the best plan. Our plan took the wreck out in one piece. Some people were cutting this or cutting that and taking it out. I'm not sure, but I'm straying a little bit here. But at 288 million, if you round that up to 300 million, I told them at the meeting that's not our price to do the job. That's our price for one calendar year, and that's how I had the accountants price it. I said take everything we talked about and price it out for 365 days. So if you figure we took 2.5 years. So that's about 750 million if you prorate it. So we weren't off by too much. But yeah, so for storms, things like that, had she broken in half, we would have just started, and said, okay, what do we do now? And kept going. And that's it. Maybe a huge major failure, they might have tried to rebid it, but because they did have the right to terminate the contract.
Yeah, I've actually two brief questions. The first one is on when you started with the initial design, what kind of factor of safety did you have? I know it was a complicated design, but in other words, how confident were you that when you eventually did this, that something wasn't just going to collapse or break or?
When we presented the bid in London, we presented it to the owners, to the P&I Club, and to a company called London Offshore Consultants, or LOC. They were the technical experts hired by the club, to vet the bids, and they were involved through the whole project on behalf of the P&I Club. So the gentleman that was sort of leading the charge from their side as one of the founders, now retired, that they brought back just for this job, and I don't know how many jobs to him in the past, and he looked at me across the table and asked me that question: how confident are you in your plan? And I told him, I said, well, hey, right now, you've given us 30 days and we've given you a concept. And theoretically, it seems to work. But we need to do a lot more engineering before I can answer that question. And he accepted that as the answer, because if I'd have tried to tell him, oh, yeah, this will work, no problem, we probably wouldn't have gotten the job. I think he enjoyed the honesty.
So were you holding your breath at that final stage, the final night?
Yeah, one of the biggest problems early on was if we try to parbuckle it, what will happen to the turn of the bilge? We had some engineers, I won't say from where, but they sent a letter to the authorities saying, oh, this plan will never work, it's going to collapse, we've done the numbers, we're expert structural guys, and as it comes over, the whole turn of the bilge is going to fail. And so yeah, we had a lot of doubters. I think after parbuckling, everybody goes, wow, this plan might just work. And it was a lot better. Mauro can tell you, after parbuckling, it was almost enjoyable leading up to refloat, because then we all were pretty confident. But until we had her parbuckle, there was a lot of doubts, no, for sure.
Just a final question. Maybe I missed it, but who paid the bill?
Everybody in this room. So here's how it works. The wreck removal falls under the P&I insurance company in London. They're part of the international group of P&I clubs. There's about 11 or 12 or 13 of them, I'm not sure. So one of those companies holds the policy. When the wreck removal bill gets to $8 million, they share the pain amongst their members, their other members. So the other IG, international group members, will pay in evenly up to, I think it's about 180 million. And these numbers vary each year. So somewhere around 180 million is still within the P&I group. After that, everything's reinsured. So they go out to the world reinsurance market. So if your car insurance went up that much and your homeowner's insurance went up that much, and it's all because everybody's trying to recoup their money. and they'll recoup it many times over. So don't feel sorry for them. Yes. It was, what happened is those different stages I talked about, the portside prep, that was one team. The platforms, one team. The holdback, one team. All those different groups almost operated independently of, the guys on board the ship had no idea what the grout bag guys were doing. They had no idea what the platform guys were doing. So it was like having multiple projects going on, and everybody was just dealing with their one project. So it kept it small in that sense for the people doing that task. And there were very few people that had a bird's eye view of the whole thing. And if you did, you didn't know a lot about what was going on. You had to really go out there and spend time with the guys to know what was really happening in that particular project. So. Mm-hmm. Oh. Biggest challenge with the VideoRay. It was funny. I remember Morrow when they was flying the VideoRay, and the blister tank. I don't know if you paid how much attention you paid, but they fit up against the hull, and there were some other objects of similar type, but there were beams fit against the hull, and if you were flying your VideoRay around, you could get the tether in between the blister tank and the hull, and you could pinch your tether. So I know Morrow lost a few strands of hair over that one. Somehow they get them stuck, and about an hour later they get them unstuck. So it's things like that. I saw tethers from this VideoRay who was filming this diver, crossed over this tether who was filming that diver, and pardon the pun, but you'd end up like a bowl of spaghetti. And they'd spend hours. No, you go over there. No, you go through here, trying to get unwrapped. So there was a lot of those kinds of issues, but a lot of them broke down. We had a lot of repairs. You guys probably got orders and orders for spare parts, but there was a team that repaired them. That's all they did all day long was repair and maintain. So I don't know if there's any one thing I would say, but just there were so many VideoRays flying at the same spot at the same time. Well, I probably had it better than most. I went over in late January, right after the accident happened, and so that was January 2012. I came home on 1st of August 2014. So that's a 2.5-year period. I was probably in the States no more than 4 months during that time period. I was lucky my wife came over and spent probably over a year, during that time on and off. And the best thing for me was that I had to go to engineering meetings. So 1 week the engineering meeting would be in Ravenna. So we're in the southwest corner of Tuscany. Ravenna, you have to drive through Tuscany that way to get to Ravenna. And next week it's in Parma, and then it's in Spinea, which is near Venice, but you wouldn't tell anybody you were going to Venice. Then it was in Milano, then to Parma, Parma ham, Parmesan cheese. Then it was in Genoa. So every week, for, 6-8 months, every week I had to get in the car, get on the ferry, go across, that's an hour. 4-hour drive just about to any of these places. So you get there in the evening, you'd have a nice meal, wake up the next morning, go to an engineering meeting. It would be all day, and there'd be some long days. But at the end of the day was another good meal. And on the third day, you get to drive back to the island. And of course, on your way, you don't go far from Castello Banfi, so you stop in and buy some wine, and then you return to the island. By the time you get back, the week's almost over, and next week you get to go to another place. So I had a lot of good breaks, but what I was I was the one that was back and forth more than anyone, trying to take what the guys were doing on site, relate it back to the engineers, and then what they were engineering, try to bring it back and say, you're not going to believe what they want you to do now. But it was a really neat time. I learned a lot about Italy and driving in Italy. It was good. We got electronic drawings, but they were all just PDFs, no AutoCAD. Maybe later on after we got the bid, I think we actually got AutoCAD drawings because Fincantieri, the builder, doesn't like giving that kind of stuff out, right? So it's kind of top secret. But we had PDF drawings to work from. We could not go on the ship. We couldn't dive around the ship. We couldn't use VideoRays to look for ourselves to see what was down there. So everything we had to work with was in the invitation to tender document, which wasn't a whole lot. And so that, did $1 billion job with very little information. But and like I said, we had some other ideas, and I was told if I said cut it up one more time, I'd be assigned to another project. I'm not so sure, having now done the project, that it would have been any easier to cut it up, because remember, she's laying on 2 ridges, and at some point you got to make that cut in the middle. And then what happens? Where does it go? It can only go down. So, okay, we'll build a platform. We'll put some grout bags in. We'll put a hold back on it, and then you're right back to where you started. So, yes, sir. That's being done now. Our partners, McCopery, are there. I was with Titan Salvage. McCopery was our partner. And so McCopery independently won the contract to do the cleanup. So they've been there a year. Amaro says they're getting ready to take out platforms. They're struggling with grout bags. The grout bags had straps, and the idea was we could grab the straps and pick the grout bags out. But what happens, you grab the straps and you pull on it, it just rips the grout bags open, and all the grout, which is hard, just clumps of grout go everywhere. So it's, I think they'll be there for a few more years cleaning up. It's a big mess. Say that again? How many fish lost? Oh, their hotel. Well, in the early days, there weren't very many fish around. And then the longer we were there, Mauro knows a lot better. I mean, he spent a lot more time looking at fish than I did. But it seemed like the longer we were there, the more fish were there, right, Mauro? And I don't know if you saw that, the octopus picture that was in one of the slides, but sharks, I don't think we saw too many sharks, no whales. We had whale watchers. We had a lot of ologists that were testing the water outside, inside. They were measuring sediment. They had traps for sediment on both sides of the island so they could pick up the natural sediment and compare it to the sediment that we were causing on our side of the island. So there's a lot of oversight from various universities in Italy. But how many fish? I'm sure some of them, I think, came to Genoa with us. I think there was some talk about seeing some fish inside that I think just took the ride. That's a good question. I would ask them to give us more time. I mean, if I can't, in my company now, I actually provide some of that kind of advice to P&I clubs and salvors and whatnot. One of the problems, if I say that I need more time to bid, and I need more information, so I need all the drawings, I need a VideoRay survey, I need underwater laser survey, I need on and on and on. You got to draw an end to that at some point in time. So maybe, and I think they believe they're better off just saying, okay, 30 days, no more. Everybody's going to waste time. Let's see who has the best plan and just go with that. what they get disappointed in, though, is they say, you told us it was only going to cost $300 million. And LOC, knowing, having worked with Salvage before, they're the experts that the P&I clubs hired, they said, you know what, I'd add $150 million to that just to be safe. So now we're at $450 million. So really, when it hit $500 million is when they started to get a little antsy. But, you know, on a project like this, you really don't know where you're going to end up or what's going to happen. And so to go back and answer your question, I would try to ask for more time so we could do a better bid. Having said that, I'm not sure if we'd ever get there or not. You know, it might take us 3 years to actually get the bid done. If you want to build a big bridge over the Schuylkill River, I bet they give you more than a year to design it and plan it and get all the permits for it and everything else. So, but technically, you know, the plan, we had to take it out in one piece. There was no way we were going to restore any buoyancy inside the ship. So the idea was, let's put all the buoyancy outside. We can control it. We can see it. We can put our sensors in it. You know, we're not going to go around and sound 60 tanks. We're going to feed them all back to the control room, that kind of stuff. And all that went amazingly well. The tow, I thought all those sponsons on the starboard side would be banging around during the tow, and you'd walk around there and be quiet. Quiet. So I don't know. I think it was a long struggle, but I would have probably rigged some of the, there's a couple ideas, but they're minor, so nothing big. There was a lot of talking for one answer. But stream of consciousness.
Yes. Was the largest shipwreck in one piece ever. What was the closest to this one? What was the most similar project in the world before the Costa Concordia?
In terms of money, there was a container ship in New Zealand called the Rena. That's still going on. They're still picking up bits and pieces of containers and cargo, and they're over 500 million, probably close to 600. I'm not sure. So in terms of money, that would be the next closest one, I think. In terms of size, you know, we were at 65,000 tons. Remember the barge we sank and we pulled the wreck up onto it and refloated it? That was 4,500 tons, and at the time, I think, say 2001 or something like that, that was the largest single wreck removal pick to date, is what we thought anyway. So this one's a little bit bigger. Yeah. But that, yeah. But we still, in the end, we refloated ours, so that's kind of cheating. But I don't know. There's never, in terms of scope and all the construction that we had to do and whatnot, there's been nothing close to it. There was an architectural contest to see who could come up with the best idea. And there was one with a big glass structure over top of it, and it was going to be a museum and a restaurant and all kinds of stuff. Giulio is a beautiful, beautiful place. I mean, the water there is as nice as I've seen anywhere in the world. It's part of the National Park System, the Tuscan Park System, no, the Tyrrhenian Sea, Tuscan National Parks, whatever. So it's, you know, if you're going to park your boat there, you're going to have to take it out. No, she had the same problem Titanic had. A few years ago, I did another competing cruise line. We refloated one of her vessels. It was a much easier project. But the same thing. The rules say you have to be able to sustain damage to 2 compartments. So basically a collision. So another ship hits right at the bulkhead and floods both compartments on either side of the bulkhead. So that's what they're designed for. They're not. I don't even know if you could design a ship that big to take a 53-meter long gash. It would be so heavy and so many compartments, you couldn't walk around, you couldn't float it. I mean, it'd be difficult. So if you damage 5 compartments, the ship's going to sink. As far as I know, There's been no, in terms of design, I don't think there's been any new rules. There may be new rules in terms of bridge management. That wasn't even supposed to be funny. Yes, sir. Yeah, I mean, I just did some work with a solicitor in London where we were looking at the performance of certain parties, and we agreed that, this is just between the solicitor and myself over the phone, that, okay, they could have performed better, but what difference would it have made? You know, if there's no damages caused by their action, then you really have no claim against them. So it goes back to, it's hard to say how much money you have to spend to engineer it enough so that you really get the advantage out of it. And, you know, there's a lot of things that we engineered that we would have never thought of in the first year. You know, they were just problems and things that came up, you know, in the second year. And we only knew about them because it might have been we were so busy doing all of this, we didn't think about that till the second year, some of that. But I don't know how, it's hard to say how much time you should give the bidders in order to save yourself money down the line. It's a tough question. I mean, even during the job, we had a hard time telling them how much it was going to cost once we were a year in. That's going to take you a few more months. And I was the lucky one that oftentimes had to tell the club, well, instead of refloating and parbuckling in June, we're going to parbuckle in September. And they're like, what? And meanwhile, CBS is on the island doing a story for 60 minutes. So, yes, sir. Blister tanks. The thought of the blister tanks really came up after that Halloween Day storm that really caused the ship to move. And we were really worried because there was quite an overhang of the bow off that forward ledge she was sitting on. So that would have been the fall of 2012. And we installed the blisters early summer 2013. It was about a 6-8 months between when we said we need them and when we actually installed them. It was pretty quick. They built those pretty quick, shipped them to Palermo. We went down and spent a couple of weeks in lovely Palermo. And it was funny because Fincantieri called me on the day they're supposed to sail, and they said, come up to the office. We're going to have a party. And we still had a lot of work to do. I said, what do you mean a party? And what was supposed to happen is they were supposed to finish everything, and then we were supposed to have a week to do our outfitting for all the valves and sensors and hydraulic pins. And they actually used up our week and then wanted to have a party. And then we're working all night long trying to get, you know, as much done as we can, so when they get to Giulio, they're ready to be picked up by the ship that's waiting on them and everything else. So those are some long, long days at a short party. Did that answer your question? Is that yes? That's a good question. We went to McCopri as a partner early on because they're more of an offshore company, offshore oil and gas, offshore projects, offshore construction. So first we went because they were Italian and you know, fairly significant company in Italy. Two, they brought the offshore side. So we said, okay, we're salvers and we're going to have to do a little bit more. We might even have to use, put together a, you know, what is it called? A Gantt chart. Ooh. And we might have to do some, you know, have some planning meetings and write procedures on how we're going to put the sponson on, or how we're going to put the platform in. I mean, so we brought them in early thinking that we would get a lot of that side from McCopri. Some we did, some we didn't. In terms of divers, we scoured, I mean, we went back to all the old jobs. There's certain companies, there's one in Seattle called Global Diving, which we used as subcontractors a lot, so we stripped guys from, or hired guys from them. But it was quite an international group, divers from Australia. We had people on the island that we said, you're director of diving resources, go find me divers. Actually, we had, you know, some of our guys, particularly the dive supervisors, have their own private list, and all the private lists came out of the desk drawer for divers. You know, for engineers, there was a great engineering company from Milan, another engineering company from near Venice, Fagioli, which provided all the strand jacks and all the engineering that went along with their strand jacks. There were people we brought in who had worked for Carnival in the shipyard at Fincantieri for the new construction for Carnival, Costa, and whatnot. So we actually drew these shipyard experienced people and put them in the shipyard, because you build 30,000 tons of steel, you need somebody there to watch out for your interest, make sure things get done right, welding details, all that good stuff, weld inspections. And there was a lot of steel that came out and went back because it wasn't done right. So you know, how do we just kept looking and looking and asking and calling is how we did it. Absolutely.
It was quite tough thing, because the working environment was a little bit particular. So the first thing I've done is check the offshore guys that I knew, but I realized that offshore and salvage, they are not the same. So a very good offshore pilot doesn't mean that it was working well in this environment. In fact, all the offshore guys have to send them home. And basically, I went through the list of people that I know, that I knew, and that I worked with. I brought them in, some senior guys, and I choose some brand new ROV pilots from the market. So no experience, just the ROV standard course. And I've tried to put them together with the senior guys. And I have guys that have started the job with 12 hours on their logbook, and they finish with 4,000. So I think we have created a good, skilled VideoRay pilots on this job. But it's been really, really difficult for the working environment. And some of the pilots must be speaking Italian, because we were also doing the communication with the crane. So the ROV pilot was flying the ROV and also flying the crane, basically. And of course they need to speak English. We were speaking English on the radio by Italians. So the Italian was speaking English on the radio. Everybody was speaking English within each other. There were 26, I think, different countries involved in this operation. So, no. Oh yeah, sorry. One day, one of the guys that I had on the job just had to left suddenly. So I was in the VIPS in Italy, and I think I went through Johnny, and I say, "Hey Johnny, do you know someone?" And I say, "Yeah, Frederick, the Swedish dealer. He's not here, unfortunately." And then I went to Frederick and I said, "Hey Frederick, do you want to come to the Costa Concordia?" And he said, "What?" I said, "Yeah, to the Costa Concordia." "When?" "Tomorrow." And he said, "Yes." So it's been really difficult. There are not really a lot of VideoRay pilots out there. There are a lot of offshore guys that work on the offshore with world class, but not really a lot specialized in VideoRay and be able to take the stress of this job. This is all about this. So I choose the guys that I knew, and the others that I didn't knew. I was trying to find something in their CV that was interesting. For example, if they were coming from the Navy or from the Army, or one was an electrician. So people with no experience, but with a previous background.
Our team included a lot of people we don't usually have. We had EMTs, we had hyperbaric doctors. And we'd have 4 HSE. Wow. We trained 300 or 400 people on climbing with harness, abseiling. I had climbing courses. The last day of the course, you had to belay yourself off the back of a 3 or 4 story hotel. If it had been half a boat length further forward toward the port, you wouldn't see the bow. Should have been like this, made it much more difficult. You would have had a lot. You'd had a lot more of the ship underwater. One of the beauties of the situation we had is the whole port side was dry, and we could do all that sponson work and then secure all of that on the port side in the dry. Do that underwater, forget about it. Once we had those anchors on that side, we could hook everything up to the other side, which actually worked better. I was very worried about how all those connections would hold up. But once you get a couple thousand tons on a 5-inch chain, it doesn't go anywhere. If it had been a half a ship length the other way, same thing. It would have just tipped right down. Most of it would be underwater. You just see the bow pointing out of the air. Those situations, I think the only thing you could have done was cut it up. And like I said, if she'd have been a boat width further out when she capsized to 90 degrees, I think they would have had 3,200 casualties instead of 32, because they were all standing on that side looking at the island. And if she'd have rolled and not caught, I think it would have been very bad. So as I've told some of the people at Costa, you were actually pretty lucky that night to only have lost 32 people. So it would have made to answer your question, it would have made a huge difference in what the salver or the contractor was going to do, for sure. Is that it? Thank you very much.